A very useful tool for an electronics hobbyist to have in their arsenal is a device known as a function generator. An entry-level one should be able to produce waveforms such as a sine wave, triangle waves, and square waves. That being said, more advanced models tend to have a broader frequency range, display screens, and even are capable of generating more complex waveforms. Of course, with the advanced features, there tends to be an advanced price associated with it, as these higher-end ones range from $100 to even a few hundred. However, an affordable option surfaced when I was one day watching GreatScott's video on the subject of a $7 function generator versus a $107 function generator. His video goes into great detail about the true performance differences between a higher-end model and this simple one. I strongly recommend you check out the video after this one, and I'll leave his video in the description below if you're interested. So after doing some brief searching, I found one on Amazon for $15. It came with some extra jumper wires and a screwdriver, so you could argue that if you just wanted to buy the function generator itself, it'd probably be about $10. So then an always satisfying part of the kit build is the unboxing. So looking inside, you can see we have the jumper wires, the screwdriver, and then the bag of components, the instruction manual inside, and then you can see the acrylic case that comes with it too. And then a resistor card. Those can come in handy too. So now we can take a look at all the components. We have the PCB and the power supply input, the resistors, both ceramic and electrolytic capacitors, the signal output terminals, we have the IC, plug and pins, pinouts, potentiometers, and switching contacts. Then there's the build instructions, which are pretty straightforward and give us a nice circuit diagram to look at. Something to be cognizant of if you buy this kit is that some of the components may be knocked around during shipping, as was the case with this pin for this IC plug. So it's simply a matter of just putting it back where it's supposed to be. Upon closer inspection, I also noticed that the pins for the IC plug a couple of them were bent. So I went ahead and straightened those up with some pliers just to get them as straight as the other ones. The same thing had also happened to the integrated circuit chip itself, with 3 of the pins being bent and having to be straightened out. So something to be aware of if you order this, just to check before you install it. One important step whenever working on electronics is to always check your resistor values, such as this 1K ohm resistor, these 3 510 ohm resistors, and then this 330 ohm resistor. Now to put it all together. So after noticing the translucent frosted characters on the top acrylic plate, I wanted to go ahead and paint those because I thought if they were black that maybe the contrast to the red board might pop out a little more and maybe even look a little better. Now the only components left for assembly were these potentiometer adjustment knobs, these acrylic sections, and then this bag of fasteners. After putting everything together, I went ahead and grabbed my DSO-138 oscilloscope to test the function generator with. And a quick side note is that I actually have a test and review video on this very affordable oscilloscope, and I'll leave that video in the description below. So after connecting the output of the function generator terminals to the probes of the oscilloscope, you can see a clipped sine wave show up. And after messing with the amplitude some, then you can start to see it refine. And then adjusting time step helped to see a clearer picture of that familiar sine wave. After adjusting the amplitude of the waveform to about 2 volts, then I started messing with the coarse and fine adjustment knobs, which are your frequency adjusters. A quick thing to mention is when it was first turned on, the operating region was in the 3 to 65 kilohertz range. If you wish to operate it at a different frequency range, then you remove the connecting link and place it in another location. In this case, I did it for the 1 to 10 hertz region. I was interested in finding out the extremes that this function generator could produce, and the low end it advertises as 1 hertz and the high end is 1 megahertz. So anyways, on the low end of the spectrum, I got the frequency down to about 100 millihertz, which I think sounds too good to be true, but since this oscilloscope is all I have to work with, then I'm going to have to go with that for now. At the other end of the spectrum, for the high frequency range, it becomes difficult for me to verify what the function generator's true capabilities are. Since my DSO-138 is limited to only 200 kilohertz, I have, however, heard that this function generator's true capabilities are right around 500 kilohertz, maybe a little less. That drawback aside, I do manage to get it to register about 225 kilohertz on my oscilloscope. For the fun of it, I also made this AC sine wave, but also to show the true voltage limitations, as you start to see clipping at around 2 volts. Now taking a look at the triangle wave feature, I relocated the contact link from sine to triangle and adjusted the waveform appropriately to get a clean looking triangle wave. I then switched the frequency range from the 100 Hz to the 3 kHz range to see how that waveform looked. I also noticed that rounding of the signal peaks would start to occur at around 1.8 volts, so to maintain a clean looking signal I kept it at about 1.5 volts. Now I wanted to take a look at the square wave feature, so I switched the output contact and tried to adjust the amplitude of the square wave, but it doesn't appear that you can do that. There isn't an adjustment for duty cycle, so it just stays at 50%, and as you can see, the square waves themselves don't really have the square wave feature at this low of a frequency. It wasn't until adjusting the frequency to 200 Hz that a clean square wave appeared. After adjusting the frequency to about 4 kilohertz, you can notice a lot of noise in that square wave, and even at lower frequencies like 2 to 3 kilohertz, there is still a lot of noise present. I'm certainly not saying that to bash on it either, as everything has its limits, and considering the cost of this device, it's pretty good. It actually does produce some really reliable signals in the low end too. So overall, I'm pretty pleased with this function generator. It performs fairly well. It's at a low cost, $15. You get additional accessories on top of that, jumper wires and a screwdriver. I'm excited to have it as a part of my tool collection, as it's actually my first function generator too. I hope you enjoyed the video, and if you did, feel free to like, share, subscribe, and stay tuned for the next one.